right, check it out. Shadows make things more interesting. Dogs barking in the background. Here we go. So we're looking at intervals of increasing and decreasing. We're also estimating and describing the extrema. So let's think about this for a second. We got two graphs. We're just going to concentrate on this one first. We're going to let this be graph A, this graph B. Let's look at graph A first. Let's just get rid of graph B for a second. All right. First of all, when it talks about finding intervals of increasing and decreasing, we have to realize that interval is referring to the x values. Over what x values was it increasing and which ones was it decreasing? So as we're looking at the graph from the left to the right, when was it increasing, when was it decreasing? Notice left to right is talking about our values of x. As we're going from the left to the right, when was it going down, when was it going up? So first, as we're looking at this from the left to the right, again, you don't have to think, I'm going to do intervals of increasing first, then I'm going to do intervals of decreasing. No, just read it from the left to the right and see what happens. As we start way over here at the left, at negative infinity, our graph is going down first. It's going down. As we go from the left to the right, as our x values are moving to the right, it's going down. So I'm going to do an interval of decreasing first. It's going to start decreasing at a negative infinity, way over here to the left at negative infinity, and it continues to go down until about right here is what it looks like, when my x value is a negative 3. So it decreases from x values negative infinity, there's negative infinity out there, all the way to a negative 3. It never can equal negative infinity, so I put a parentheses right there. And it's not actually decreasing at negative 3 because that's the point at which it changes direction. So we call that a turning point. It's not going to increase or decrease at that point right there. Well, we continue a little bit further. Notice the next stretch of this graph, it increases as we continue to the right. So it starts increasing right here. Notice this little stretch from negative 3 to what? A negative 1. It increases right there. So from negative 3 to negative 1, it was increasing. Again, it doesn't actually increase right there at negative 1, so I put a parenthesis around that. As we continue to the right and we go to a positive 1, notice right there at a positive 1, it was decreasing between these two x values. So from negative 1 to a positive 1, it was decreasing right there. And then from that positive 1 all the way to our positive infinity over here to the right, it's increasing from positive 1 to positive infinity. So our two intervals of increasing are from negative 3 to 1 and from 1 to infinity. Those are the two times it's going up. Decreasing from negative infinity to negative 3 and from negative 1 to positive 1. And really just a beautiful way to write these and put them together. It's increasing from negative 3 to negative 1, and I'm going to union that with 1 to infinity. These are not overlapping, so it's not an intersection. I'm just putting them together. It's decreasing from negative infinity to negative 3, union with negative 1 to positive 1. So we can put them together. Let's look at extrema. With extrema, extrema is a fancy name for turning points. We're literally talking about those 3 points right there that we were just using to find our intervals of increasing and decreasing. So when we're looking for our turning points, well, we can have relative extrema, which is saying, hey, this is relatively a low point or relatively a high point, or we can have absolute extrema. Notice that this point right here, this turning point, is the lowest point on the entire graph. Nothing gets below this point. So we have an absolute minimum at that point 1, 0. These two are not the lowest point in the entire graph. They're also not the highest point in the entire graph, because clearly these arrows are saying it's going even higher, but anything around it is going to be greater than this point. So locally, relatively, this is the lowest point in this area. So we have a relative minimum. Spelling. At -3, +4. And we have a relative maximum at this point here. -1, 1, 2, 3, 4, 5, 6. -1, 6. Because, well, this is clearly not an absolute. It gets greater values than this clearly, but there's nothing higher than that around that point right there. Relatively, that's the highest point.